Let me start with a puzzle. We make a list of three numbers and call it A. Then we write B equals A. Then we tack 100 onto the end of A. Here is the question. We never touched B. So what is B now? The original three numbers? Or the four? With the 100 included? The answer surprises almost everyone. Both A and B show the phone number list. Writing B equals A did not copy anything. It just gave the very same list a second name. By the end of this lesson, that will feel obvious. We'll get there through lists, tuples, sets, and dictionaries, and we'll watch each one move. A collection is just one object that holds many elements. Python gives you four workhorses, and telling them apart is the whole game. First, the list, an ordered row of items you can freely change, written with square brackets. Second, the tuple. It looks like a list with round brackets, but it is frozen. Once built, it can never change. Third, the set. Curly braces, no colons, and it enforces two rules. The order is not guaranteed, and every element must be unique. And fourth, the dictionary. Curly braces again, but now each entry is a key pointing to a value, a tiny lookup table. Meet a list of four numbers. Picture it as a row of labeled boxes, and the labels are what matter. Python counts positions from 0, so 10 sits at index 0, 20 at 1, 30 at 2, 40 at 3. So nums at 0 reaches into the first box and hands you 10. And here is a lovely shortcut. A negative index counts from the right. -1 is the last box, 40, without ever knowing the length. Now slicing, nums 1:3 means start at index 1 and stop just before 3. The stop is excluded. That trips people up. So you get positions 1 and 2 only. Lists are mutable. They change in place. Watch. We start with 10, 20, 30, 40. Append 50 adds one new box on the right. Insert at index 1, slides 15 into the second slot, and shoves everyone else right. Pop, with no argument, removes the last box. 50 is gone. And remove 15 deletes by value, not position. It finds the 15 and pulls it out. We are back to 10, 20, 30, 40. Now let's solve that opening puzzle for good. A is a list, 5 and 10. Then B equals A. The crucial truth: this makes no new list. It hangs a second name on the exact same box. A and B both point there. But A with a full slice, A colon, is different. That really does build a fresh, separate box. C points to its own copy. Same contents today, but a different object. So append 15 to A. It grows the shared box. And because B is just another name for that same box, B sees 15 too. But C, the true copy, is untouched. That is the whole mystery. Undone. A tuple is a list's frozen twin. Round brackets instead of square. You read from it exactly the same way. T at 0 is 10, but you can never change it. Think of the boxes as sealed shut. One trick you will use constantly: unpacking. X, Y, Z equals T spreads the three values into three names at once. X is 10, Y is 20, Z is 30. And the moment you try to write into a tuple T at 0 equals 99, Python refuses and raises a type error. Immutable means immutable. Why care that they are frozen? Because being unchangeable makes a tuple safe to use as a dictionary key, like naming grid points by their coordinates. A list could never do that. Frozen is a feature. A set is a bag of items with one iron rule: no duplicates. Toss in 1, 2, 2, 3, and the second to simply vanishes. What remains is 1, 2, 3. Length 3, not 4. Sets quietly deduplicate for you. Sets really shine when you combine them. Picture set A and set B as two overlapping circles. 1 and 2 live only in A, 5 and 6 only in B, and 3 and 4 sit in the shared middle. Union, the vertical bar, is everything in either circle, 1 through 6. Intersection, the ampersand, is only the overlap, 3 and 4. And difference, the minus, is what is in A but not B, just 1 and 2. A dictionary maps keys to values. Here to students map to their marks. Picture it as a column of key arrow value rows. RAM to 85, Seema to 92. Looking up is instant. Marks, bracket RAM, jump straight to 85. No scanning. The key takes you right there. Assign to a brand new key. Arjun equals 78 and the dictionary grows a new row. But assign to a key that already exists. Ram equals 90 and no new row appears. The value updates in place. The length stays 3 because Ram was already there. And del marks Seema removes that whole row, key and value together. Here is a classic pattern worth memorizing. Counting how often each word appears. The trick is d.get. It fetches a key's current count, or 0 if the word is new, so you can always add 1 safely. First word, the it is new, so get returns 0, plus 1 is 1. Next cat, also new. Its count becomes 1. The again. Now get finds 1, and 1 plus 1 is 2. Dog, new, count 1. The a third time. 2 becomes 3, and cat once more. 1 becomes 2. Done. And there it is. The appears 3 times, cat twice, dog once. A whole frequency table built in 4 lines. A comprehension is a one-line factory that builds a new list. Read it left to right as a pipeline. The source is range 5. The numbers 0 through 4. Each number flows through the transform, n times n, squaring it, and drops into the output list 0, 1, 4, 9, 16. You can also add a filter. This one walks 0 through 5, but keeps a number only if it is even, if n mod 2 is 0. So the odd ones, 1, 3, 5, are dropped and only 0, 2, 4 survive into the new list. And the same idea builds dictionaries. This maps each number to its square 0 to 0, 1 to 1, 2 to 4, 3 to 9. The comprehension is Python's most beloved one-liner. Learn to read it, and your code shrinks. Your turn. Same counting pattern, but now we count the letters in the word banana. Pause the video, trace it letter by letter, and predict exactly what the dictionary prints. I'll wait. B is new. Count 1. A is new. Count 1. N is new. Count 1. A again. Its 1 becomes 2. N again becomes 2. And the last, A, 2, becomes 3. Final answer. B appears once, a 3 times, N twice. If you predicted B1, a 3, N2. You have genuinely understood how dictionaries accumulate. Well done. Trap 1, the big one. B equals A shares the object. Change in place and B changes with it. For a real copy, slice with A colon or wrap it in list. Trap 2, plus builds a brand new list and leaves the originals untouched. Only append and extend actually mutate. Don't expect x plus y to change x. Trap 3. A set silently throws away repeats and it has no positions at all. So asking for s at 0 is an error, not the first element. And trap 4. Reassigning an existing dictionary key just updates its value. The length only grows when the key is genuinely new. Let's lock it all in. A list is an ordered, changeable row. Append and extend mutate it in place, while plus hands back a fresh list. A tuple is that same row, frozen, which is exactly what lets it serve as a dictionary key. A set is an unordered bag of unique items with union, intersection, and difference for combining them. And a dictionary maps keys to values for instant lookup. Overwriting a key updates it without growing the count. Name the type, ask if it's mutable, and watch for aliasing. Do that, and these 4 containers will never trip you up again.